Okay, I'm gonna use at least 3 different colors to just illustrate this. I think it just makes it a lot easier to look at it later. So when we're calculating the height of a triangle, why would we want to do that? In several instances, it will be necessary to determine the height of a triangle, right? We're going to explore this a little further, determine the height of this triangle below. So first I'm just going to show you how you could do it without knowing what you're about to find out. By the way, when the straight line is at the bottom, this is our base, and then the height is measured at a 90 from that base, right? The height and the base meet at a 90, right? We could have a scenario where the triangle is kind of like flipped upside down, in which case this is still, we would still consider it, it's the same idea that it's the height of the triangle, but we would call it depth in this case. Okay, but it's the same idea. It goes to from the straight line and makes a 90 degree to the tip of that triangle. Okay, so same idea here. Now, our goal is going to be to find this height right here. Okay, if you introduce that dashed line, it's not always going to be dashed, but in this case it is. You're splitting this triangle up into 2. What kind of triangle? Right triangles. So if there's a 90 here, folks, there's definitely a 90 on this side as well. The question will just never bother doing that, but you've got 2 right triangles. Okay. So let's cut this triangle up and work with one triangle at a time. So I'm going to take number 1 here and just replicate it as best as I can. This is height. This is 59.8 at the corner here. Weird angles, I know, but I'm using GeoGebra and it's often drawn to scale. Okay? 59.8. This is 4.52 feet. Okay? So we've got everything we need here. And I'm going to highlight this part orange because it's the same as the height inside that larger oblique triangle. Okay? Now, let's see how, can we use sine law to perhaps find the height here? Do you have a pair? Yeah. Yes, you have a pair. Okay, so we could use sine of 90 degrees, which you're going to soon find out it's 1. It's always 1. Okay, and then, so that's over 4.52 feet. And on the other side, we could go sine of 59.8 degrees over h. Let me zoom into that a little bit because I feel like I might need a close-up of that. All right, so let's find our height here. Height is, right, we cross multiply and divide. So it's 4.52 times sine of 59.8 degrees divided by sine of 90. Let's find our height. That's 4.52 times sine of 59.8. That's 3.90. Watch what happens when I divide by sine of 90. I'm going to blow your mind here. See, I told you I was going to blow your mind. Sine of 90 is 1. So if you divide by sine of 90, nothing really changes because you're dividing that by 1. It just gives you the number itself. So 3.91 is our answer. Write that down. Okay, so we got that. Now we're going to continue. Page 17. Now we're going to split this up. And just to prove a point, I'm going to use this triangle on the right side. and show it to you that you're still going to get the same answer. It still should be 3.91 for this. Okay, so we're going to try to replicate. This is h. This is 7.1 feet. This is 33.4 feet. Oh, sorry, degrees. Oh, maybe let's talk about the common mistake. You wouldn't fall for it, but I know people that do. Okay, 8.2 feet. Can I copy that down here? Can I take this number and put it down here? Because this is implying it goes from end to end, right? So don't use it. Okay. Quite often I see that, so be warned. Do you have a pair here? Absolutely. So we're going to do the same thing. Sine of 90 over 7.1 feet. Then it's sine of 33.4 over h. You do the same thing. H is 7.1 times sine of 33.4 over sine of 90. What's sine of 90 again? It's 1. So if you want to write that on the side here, I might do that in a bit. Let me just finish this work here. 7.1 times sine of 33.4. I'm just going to show you, right? It's that. If I divide that by sine of 90, it's still the same. So 3.91 rounded. Which is what we expected, right? And sorry, I'm going to highlight this height orange again, right? That's what we're finding here. That's what we found. And on the side here, I will just say that sine of 90 degrees is always 1. You can't see that, now you can. So regardless of which triangle you use, when you slice it up, you can find the height of the triangle. Just look at it carefully. What did we need? Like if you look at this original triangle, what did we have each time? We had these slants, right? The slant. And same here, we had that slant, which allowed us to find the height. So focus on, you need one of these slant sides to figure out the height. Remember that. So let's give you the shortcut, because I don't want you to do this every time. It's way too much time that you're going to be spending. There's a shortcut. I don't know if you see it. Like maybe you're smart enough. Watch this. To figure out the height, what did we do? We multiplied 4.52, this side right here, times what? Times sine of the angle that's adjacent to it, right? What about on this other side? What did we do here on this side? We took the slant, and then we multiplied it by sine of the one that's adjacent to it. That's your shortcut right there, folks. And I'm just going to formally show you down here. I'm going to give you 3 scenarios because triangles look different. Sometimes it's the way we always see it. Sometimes it's upside down. And then you have your obtuse triangle. How do you deal with that in that case? That's where my several colors come in, okay? So I'm not going to use orange now. I'm going to use like green and pink maybe, or whatever 2 colors you have. It doesn't matter. Just be consistent. So if I give you triangle PQR, if you draw it out like this, if you wanted to find the height, you would go side PQ or QP, it doesn't matter, right? And you would multiply it by sine of angle. What's this angle here, right? That's angle P. That's how you would find out. So I'm gonna highlight this using pink. So I take that side, and then I multiply it by the angle that's touching it. Should I specify even more? It's the angle that is formed with the base, right, in this case. Let's go over to this one. Triangle DEF, right? You sketch it out, and I ask you to find the depth of maybe maybe this is like two mountain tops, right? And I want you to figure out the depth, right? Or this is like an ocean. This is the top of the ocean. I want you to figure out how far down is the ground. And so what you would do there, same thing. Let's focus in on, right? We could say this side here. If you know this slant, right, you would multiply it by the angle here. So to find the depth, you would go side FE or EF, it doesn't matter, times sine of, in this case, angle E. And I would have this on my study sheet, to be honest. It's nice, at least one scenario. You don't have to have all three scenarios. But finding the height, just put it on your study sheet, finding the height of a triangle. Just say I need a slant. I would also put a note to myself, like I need a slant to figure out the height. And what about this one? You notice that the height is outside the triangle itself? It's kind of weird, but that's how it is. If something were to be slanted like this, to measure the height of this building, you would go straight down to the ground, correct? So the height is actually out here, but same thing, you would just grab, this is a slant, right here. You would grab that one, and then in this case, you multiply it by that angle there. So the height is QP, or PQ, it doesn't matter, times sine of P. And there, I hope you see the pattern here. Right? That's all. I just did this to help you figure out the pattern. So either you write this down for yourself up here, or you simply copy down. I would just copy one of these scenarios. If you have room, do all three, but I don't think it's necessary. So I will just say, note, you need to know one slant. And by slant, I mean, I don't know if that makes sense. A slanted side is not straight horizontally or vertically. It's always in a little bit of an angle. It's diagonal. Should I say diagonal? And I'm going to highlight slant or diagonal. Like that's what I mean. Like in this case, all the pink highlighted are slanted sides. Okay. It's Thursday, feels like Monday, right? Let me just tell you, I'm not going to show you every scenario, but watch carefully. If you knew this slant height here, or not slant height, just call it a slant. If you knew QR, you wouldn't multiply it by this angle here, I'm hoping. You would multiply it by the angle right here in this corner. Right? Same here. If you knew DF, I really hope that you would multiply by sine of that angle right there. So that is the pattern I want you to observe. That's how we do it. Okay? So if we go up here, watch, I'm going to go up here and do it one more time with you. Grab whatever you highlighted the slant with down here. We're going to come back up and do the same thing here. This was our slant. This was our slant. What did we do actually? All the way down here. Follow my finger. The 4.52, there it is. And the angle, I used green for the angle. This one right here. Okay, that is the angle right here. So we did that as well. We went slant times sine of the angle adjacent to it, with the base, I should say. Okay. I know some of you might be like, well, angle C is also adjacent, right? But that one is touching the other diagonal, right? So that one is out of the question. It has to be touching the base. I could do the same thing on the other side. I don't know if I want to do it because it will be it's almost like a coloring book. I don't know if I want to go there. So I'm just going to leave it like this. I will highlight the fact that sine of 90 is always 1. So you, right, like it's a good, then you don't even need to bother entering that into your calculator because dividing anything by 1 doesn't change anything. All right. Let's put this to the test a little bit. Let's go to extras on page 18. So this is just a concept. I'm just going to throw it in there. Questions are just going to have it. It's like, what's the height of this triangle? And you will have already done a bunch of work beforehand, most likely, to figure that out. We're gonna, I really want you to focus on this part and down, but this one is an interesting one. I want you to know how to do one of these, okay? Because if you think about it, you only have one side and one angle. That's all you have at first sight. But if this side is the same as this one, technically the 15.9 comes over here. Okay. Can you solve that one as is? Do you have a pair? You don't, right? But we have an isosceles triangle, don't we? We could easily find out these two angles if we wanted to, because we have an isosceles triangle, okay? So we will, to find angle X, which is also the same thing as angle Y, we would simply go 180 minus 72. Okay. I'm ahead of myself here. That's already 108, right? But we got to make sure we divide that in half, right? So if you take away the 72 from 180, the remainder will be split evenly. So you have 108 divided by 2, which is 54. So this is kind of like a special case which shows up from time to time. So now I'm going to grab my red pen if I find it. I'm just going to say the 54 is actually here, and it's over here as well. I'm going to highlight the fact that this is an isosceles triangle because I can give you less information and you can still be able to solve it if it's an isosceles triangle. So do we have a pair now? Yeah, you've got one here and you've got a pair here. So which pair do you want to use? It doesn't matter, right? They're the same. They're exactly the same. So sine of 54 over 15.9 miles. And then sine of 72, that's the side we're missing, right? So Z, side Z is what is unknown yet to us. Over Z, I will do that over here. Z is equal to 15.9 times sine of 72 divided by sine of 54. If you crunch this, you get 18.69 miles. Does it make sense? It's a little bigger than the other ones, right? The angle across from it is the largest angle. So, okay, we're good. I'm still not saying it's going to be right every time, but at least you know you're not off, right? You're not like way off. Did we solve the triangle? We actually did. We solved for all angles and all sides. So this helped us out though, right? The fact that these two sides were the same is really gold. That's what helped us out there. So this was honestly just an aside, and but at the same time we reviewed sine law. So over here, A to C, I want you to calculate the length of the indicated side. So wherever there's a question mark, I want you to solve that. But then we're going to take it a step further and figure out the height of this triangle as well. Every single triangle, like this one right here, folks, the height is actually out here. Okay? You can actually sketch this in if you want. This is the height. So you're going to first find Z, that's the indicated side, then find the height using that shortcut I showed you. Okay? For B and C, let's do the same thing. Watch carefully what I do with B and C. So for B, the height is going to go from the top, angle L, straight down to the bottom. So if I don't put the dashed lines in, then you just imagine, right? You just introduce that yourself. And then the last one, what's up with that one? Whoa, right? Yeah, it's a little slanted, you notice that? So, but this is the base here. So from that base, go to P like that. And so this is your height. Or this is depth almost, right? Still the height of the triangle. Just rotate it until it looks like a regular triangle in your brain, right? Yeah, I'm just going to leave it at that. So solve for the indicated side, wherever the question mark is, and then I want you to solve for either the depth or the height. So let's take some time. And so this is just a little topic, actually. And then we'll do, we'll start cosine law. And we'll be able to solve all triangles that you could possibly encounter. Find the height of the triangles. Do not worry about the question marks. Because remember, if you have a slant, if you have one slant, you're in business, right? You just need that angle that's touching it. So yeah, this one, again, you've got two slants on this triangle, right? But this is the one you know. So you want to multiply it by this angle right there. Right? So that's how you want to calculate your height. So it's 1794.3 times sine of 15. It's okay if you did it the long way. For now it's okay, but I think this will save you a lot of time. So this is going to be 464.40, okay, for the height itself. If you had known this slant here, you just multiply that by sine of 132, you should get the same answer if everything is going right with your calculations. On this triangle, for example, if I asked you, hey, just find the height, it would make more sense to focus on this slant that you know, right? And then just multiply it by this angle right here that's touching it. So we're going to go, height is 15.9 times sine of 43. I appreciate, some of you did it the long way. There's nothing wrong with that because you still you show understanding, but I think down the road you might want to save some time doing these. Over here, this is the slant right? So this would be the angle that we would want to use. It for sure not be 40 because it's not touching it, right? But sometimes students use this one that's touching both slants. Don't use that one, okay? If you ever know what that is, don't use that one. Height is 36.3 times sine of 34. So if you multiply that out, you get 20.30 centimeters. In this case, it's all centimeters. Oh no, we had meters on the top. Forgot to put meters down. So there you have it. Let's keep going. Why would you want to know the height? Sometimes it's just going to ask you flat out what's the height of this object above the ground or whatever. Sometimes you want to find the area of the triangle. So I don't know if you remember base times height divided by 2. Do you remember that one? I think it shows up somewhere here. So I'm going to put this on hold. I'm going to stop this video here actually. This is